Hi, in today's lecture we will be learning about exponents, which you'll learn on eventually will be a large factor and repeated multiplication. First off, we will be learning what exponents are. An exponent is a numeral or variable to the top right of another numeral or variable called the base. For example, here we have a base that's 3 and an exponent that's 5. How do we use an exponent? When we use an exponent, we use a chosen number, and which will be our base, and write another number to the top right of our base, which will be the exponent. The value of the exponent is equivalent to the number of times we multiply the base by itself. For example, we have 3 to the 5th, 3 to the power of 5. That would mean 3 times 3 times 3 times 3 times 3. You can easily notice that 3 is multiplied 5 times, and the exponent, which is 5, is equal to 5. Every exponent rule applies to decimals and fractions as well. Exponents 0 and 1. When the exponent is 0, the base exponent number is always equal to 1. When the exponent is 1, the base exponent number or expression is always equivalent to the base number. For example, if I had 4 to the power of 0, the answer would be 1. If I had 4 to the power of 1, the answer would be 4. Negative exponents. When dealing with numbers with negative exponents, you need to make the exponent positive, and the answer would be the reciprocal. For example, if I had 4 to the power of negative 2, I would change it back to 4 squared and find the reciprocal, which would be 1/16. Since 16 equals 4 squared, and the reciprocal of 16 is 1/16, the answer would be 1/16. Fractional exponents. When dealing with numbers with fractional exponents, you need to convert it into roots. The base would be the number you're finding a root of, a certain root of, and the exponent would be the kind of root. You can convert the decimal exponent into a fractional exponent if it helps and if it pops up. For example, if I had 4 to the power of 1/2, that would mean the square root of 4, the square root of 4, which would be 2. Decimals and fractions exponent tips. If the fractions or decimals are less than 1, the value of the fractions or decimals with exponents will always be less than the base. Just like 0.5 or 1/2 to the power of 2, which would be 0.25 or 1/4. The negative exponent rule always also applies to decimals and fractions. When using the negative exponent on a fraction or decimal, the fractions forms reciprocal with the same exponent but positive would be the answer. For example, if I had 1/2 to the power of negative 2, I would convert it back to 1/2 to the power of 2, which would be 1/4, and the reciprocal of 1/4 is 4. When using negative exponents on a decimal or fraction, the answer or equivalent number is always greater than the base. With negative decimals or fractions with negative exponents, the equivalent is less than the base. For example, 4 to the power of 1/2 or 0.5, which is equivalent to 2. Exponents of arithmetic. When dealing with different numbers with exponents with different operations, for example, addition, subtraction, multiplication, division, first you need to solve for each number in the operation. Then you just follow the operation. For example, if you have 4 to the power of 7 minus 4 to the power of 4, you need to work everything out first. That would be 4 to the power of 3, and the difference of 4 to the 7th and 4 to the 4th, they will be completely different things. Here are some examples for you to work on. You don't need to work on all of them, or you don't need to work on any of them at all. You can just follow along and listen to the answers. I'm gonna take some time for you to pause this video and find out the answers for each or some of these. Alright, now that some of you have solved all of them, it's time to show the answers. For number 1, or 2 to the power of 3, or 2 cubed, the answer is 8. Number 2, 4 to the 2nd power, or 4 squared, 16. Number 3, yes. Number 4, 1,000. Number 5, no. Number 6, 0.25, or 1/4. Number 7, 256. Number 8, 2,401. Number 9, 48. Number 10, 42. Number 11, yes. Now that you know everything about your exponents, it's time that you may be able to work on some. And this is the end of the lecture. Bye. See you in the next lecture.